Hey everybody, and welcome back to another fun and exciting pre-calculus class. In today's lesson, we'll be in 12.7 in your book. That's on page 253, and 12.7 is the last lesson in chapter 12, so hang in there. I know this has been a challenging chapter, probably one of the hardest ones in the entire book, but just keep pushing forward. You're almost done. All right, so let's go ahead and jump into this. Let's look in the book. What we're doing here is we're rotating. So we're putting the conic section, right, on the graph. And now instead of putting it right where we want it, we're taking and we're rotating, if you will, the axis a number of degrees. So it's like taking the Cartesian plane and rotating it maybe 30 degrees, 60 degrees, however much they tell us to rotate it. All right, so take a look here. All conics from this form, I'm not going to read the whole thing, so far have had b equals 0. B is this xy. We haven't seen this xy yet. When b is not 0, the equation is often more difficult to graph accurately. In this case, graphing is simplified by graphing with respect to the rotated x and y prime axes. Rotated axes are shown in figure 12u. So here we go. This is like our x right here, and then we rotate it up a degrees. What is a? It changes all the time. So this is alpha, so we're going to rotate it alpha degrees. Notice that the y also rotates alpha degrees. Let's go ahead and keep going down through this. This is a lot of valuable information right here. To derive formulas from the rotation process, consider any point on xy with respect to the rotated axis. So if you look at this figure right here, the idea is like, okay, if we take this x and y value and then we kind of remeasure the old x and y against the new x and y, for the prime axis, so this is the x, this is rotated x, so it's x prime. Well, what happens if we do that, if we kind of calculate that into it, then it will rotate itself. We don't actually have to do the rotation when we figure it in or when we kind of like layer it in there on top of it. It will rotate all the points for us. Here is kind of basically the derivation of that. We don't necessarily need that. Here's what we need right here. Conic rotation of axis formulas. This is important. Write this down. You'll need this on these. Now, you're not going to have a lot of these on your quizzes and tests, but you're going to have one, so you need to know how to be able to do it, and you need to know these formulas to get it done. All right, so here is our example 1. Graph 17x squared minus 12xy plus 8y squared equals 20. Notice this is new. Okay, this is brand new information right here. We haven't seen this before. Here's what this is. This is what we're going to try to rotate in by using the alpha equals tangent inverse tangent of 2. All right. Use the rotation formulas to rotate it in there. Now, here's our rotation formulas. This is somewhat complicated, but let me try to break it down for you. Since alpha equals tangent -1, which is inverse tangent of 2, and tangent of alpha equals 2, how do you get that? Let's skip over here to my screen, and if I take tangent -1, if I multiply, since this is an inverse, if I multiply both sides by tangent, that's going to cancel that, and I multiply over here by tangent, I get tangent of alpha equals 2. Okay? Now, we know that from our different studies of trig, we know that tangent equals what? Opposite over adjacent. But in trigonometry, that equals y over x. Okay? So if we turn this into a fraction, 2 over 1, we would know that y equals 2 and x equals 1. That's going to be important, so let's write that down up here. X equals 1, y equals 2. What else do we need for all of our formulas in trig? We need our r, but we don't know that right now because all we know is this. So how would we figure out our r? Well, you could plug it in, you could use the unit circle, you could do different things, but we could plug it into Pythagorean theorem and get a squared plus b squared equals our c squared. Take the square root of that, and we're basically going to get, and it doesn't matter which one's x and y, so we'll say 1 squared plus 2 squared equals c. We'll take the square root of that, and we will end up with 1 plus 4 equals 5. So the square root of 5 equals c, or r. So r equals the square root of 5. This little chart, this little box, you're going to need this. Something else that we can do from this information is we can do our all students take calculus. All right, so let's go ahead and kind of see where we're at. Notice that our tangent is positive, positive. Where is tangent positive? First and third. So again, more valuable information that we need, and then we can figure out from there. Let's jump back over to the book on page 253. And from here, we can see that our point, our rotation point, is our xy. Our xy is our 1, 2. So if you come over here to the graph, our rotation point would be our 1, 2, square root of 5. This triangle right here. This point at 1, 2, very, very important for us as we're continuing through this. That's what everything is going to be based on, is this point right here. Now, the other thing that's important is that now we know what the sine of alpha is. Because if we go back up here into our table, into our formula, we need to know sine of alpha and we need to know cosine of alpha to make this work right here. So with our rotated axis, so basically we're taking this axis right here, we're rotating it up, so now the x is going to be on this square root of 5, this hypotenuse. Our x rotates, it curves, it twists up into this point, okay? So kind of think about it right here. We had our x right here, and we rotate it. We're rotating our whole triangle. This whole triangle is rotating up into this point on this right here, 1, 2. So you're twisting it up into that spot. Very important to kind of comprehend what it's doing, because I want you to get what it's doing, because if you don't get what it's doing, you're not going to understand. Because when I flip this page, you're going to go, wait a second, what is happening right here? This is what's happening. Okay, the math behind it won't make much sense if you don't get this. Now, so our sine is going to be 2 over square root of 5, y over r, and our cosine is going to be x over 5, 1 over 5. All right, let's turn the page. You ready for this? All right, there it is. I told you, you can be like, wait a second. All right, look at all this. What is this right here? Here's what this is. This is our formula. This is it with everything plugged into it. X prime minus 2y prime over the square root of 5. Here's our y point plugged in. Now what we're going to do, so you say, what is this right here? Here's what this is. This is the information right here. All right, what is that? That's our formula that we used going back to this last page. This is this chart right here, table I, with all of this information right here plugged into it. And then what? Then we take this and we plug it back into the given equation. They gave us this equation right here, 17x squared. What is this x squared? Well, we take the x prime and we shove it into this x squared. We take this xy and we shove it into the xy. We take this y and we shove it into the y squared. It's like we're taking everything and we're putting it into the formula. It's just substitution, okay? So let's go back over here. Once we get it subbed in, it looks like this. So here's our 17 x prime minus 2y prime over the square root of 5. Where did that come from? It came from right here. It came from our chart. You just plug in and it gives you that. Notice x prime times 1. There it is, x prime times 1 is just x prime, minus, there's your minus sign, y prime times 2. There's our y prime times 2. We had a common denominator, so we can put it all over 5. All we did was subbed into our formula. That's it. I know it looks complicated. It's not. It's just a substitution and a multiplication. Take this, once you get this, this is now the x value. This is our x prime. We're going to sub it in for x, anywhere that you saw an x in the original. Okay? So now we have this 17 times, this is x squared. This is our original. 17 times x squared. Now, this gets a little bit complicated right here, and I want to show it to you. What did they do? How did they get from here, 17 times x prime minus 2y prime over the square root of 5 squared, to this? How did that happen right there? Let me show it to you, and I think that I can make it make sense to you. All right, so here it is. This is basically this is what they give you, and then all of a sudden it looks totally different than that. So how do we solve this? Well, we're going to do order of operation right here. So we're not going to do the times 17 yet. We're going to do this square first. So we're going to do x prime minus y prime over square root of 5 squared times x prime minus 2y prime over square root of 5. So we're just going to multiply these two things out. I'll do the denominators first. That should be pretty easy. That's going to equal the square root of 25, which is 5. Now, this numerator is a little bit more complicated, but it's not terrible. We've done these a million times. So we're going to do firsts, and we're going to get x prime squared, and then we're going to do the outers, and we're going to get minus 2x prime y prime, and then we're going to do the inners, and we're going to get another negative 2x prime y prime. Let's extend this, and then we're going to do the last. So then we're going to get our positive 4 y prime squared, and that's all over 5. Let me center this a little bit better so it looks better. Now what do? Now we can combine these two pieces right here, and we're going to end up with x prime squared minus 4x prime y prime plus 4 y prime squared over 5. And that's all times 17. Now, in order to get rid of this denominator in here, which we don't want to deal with that's nasty, right? We can basically just pull this denominator out and put it over this. So 17 over 5 is the same as this. Why is that? Because this is a multiplication problem. This is 17 over 1 times this. So in order to do that, we can just pull that 5 out right here, and it ends up being the same one. The 5 goes out here, the 1 comes out here. It's a little bit complicated algebra right there, but as soon as you kind of get that, I think the rest of this will make sense. Let's jump back over to the book, and this is what they did. So they took this, they squared this, and here's their x prime squared minus 4x prime y prime plus 4y prime squared. That's what we got too when we did our math. So then they had the 5 underneath here when they did this, but they were able to get rid of it by pulling it out front. They did that on all of them. Since they're all square root of 5 denominators, they pulled them all out. And then we're left with this massive polynomial. What we want to do now is get rid of all these fractions. Since they're all the same, we multiply everything by 5. So this gets multiplied by 5, and then they do 2 steps right here. I don't like the way they're doing this, but they multiply everything by 5. That cancels denominator, cancels denominator, cancels denominator, and 5 times 20 is 100. That's where the 100 comes from. Then they take the 17 and they move the 17 through. So there's two separate steps going on here. First of all, you're canceling the 5 by multiplying everything by 5. Secondly, you're distributing. So here they distribute the 17 through, 17 x prime squared minus 68 x prime y prime. I think you get the idea. Then they do the 12 that goes through here, 24, 36, 24. And then they put the 8 through this one. So 8 times 4 is 32, but they've already canceled the 5. That's important to know. And this is like, when I first looked at this, I was like, what are they doing right here? It took me a minute to kind of, work through this progression, but they've skipped a couple steps, I think, just to save a little bit of paper, because this is already a ton of work right here. All right, so notice this. When done accurately, the coefficient of the x prime y prime term will always be 0. In other words, when we figure this all out, we're going to come out with 0. What have we done here? Here's what we've done here. We've canceled everything out. Look, minus 64 x prime y prime. Here's another x prime y prime, 36. You subtract that out and you get 32. And then here's another x prime y prime, which is 32. You subtract that out and you get 0. This zeroes out every time. That's what we're doing. We're canceling that term because it's almost impossible to graph it with that term. So we want to cancel the term. That was the whole process up here, was going to cancel this term, this x prime, y prime term. We want to get rid of it. Okay? Then we have this. We get rid of this and we divide everything by 100. X prime squared over 4 plus x prime squared over 1 equals 1. Now we have it into, finally, hey, can you believe that? That whole thing kind of got all the way down to this right here. And then once we get there, we can say, okay, let's go back to figure out, what is this? Is this a hyperbola? Is this a parabola? Is this a ellipse? What's going on right here? Well, it is an ellipse because it follows the standard form of ellipse. Once we figure out that it's an ellipse, we can go ahead and start graphing it. Now, I'm not going to take the time to go back over everything that you know already how to do about the ellipse. I have another video on that. You can go learn how to graph an ellipse if you don't remember. But we need to find our C. We already have our A and our B right here. So we just go to this A and B. A is 2, B is 1. Figure out your C. It's 1.7 roughly. And now you're ready to go ahead and start graphing all this stuff. You would put your foci, you would put your vertex, you would do everything that you know how to do, and you would graph your ellipse. Once you get it graphed down there, you'll notice that it's kind of weird shape. We had been graphing them perfectly centered on the X if it was horizontal, or perfectly centered on the Y if it was vertical. Now it's not going to look like that. It's going to look oblong. It's going to look different, but you still have your rotated X and Y axis, which are straight. Put all your stuff on there, draw your graph, and that will be your rotation. You don't have to rotate it anymore. You don't have to rotate these points. We rotated it up here. All this disgusting, algebra work right here, right? That was your rotation, okay? So once you get it rotated, then everything else falls into place, graph it, and you should be good. All right, look over here on the next page, bottom of that page, 254. A was given in the example we looked at. Now they say, well, what happens if they don't give you A? Well, what we want to do is we want to do this kind of almost a system of equations with the general conic equation. So we're going to take the general equation, then we're going to take our two rotation equations that were in table I, we're going to put them together, we're going to delineate that out, and we're going to end up with tangent to A equals B over A minus C. Basically, depending on the values A, B, and C, several different things can occur, but what's happening here is you're going to have half angles, double angles, you're going to have different things. It gets somewhat complicated right here, but here's the rotation angle formulas. Keep these in mind, okay? Now, how do you get there? Let's jump back to, now look at this, sine of A. So we go from tangent of 2A. We have to cut that in half because we don't want 2A, we just want A. Notice sine A. How do we cut an angle in half? Go back to the front cover of your book, which is page B for me, and you'll notice that we have half angle identities. So the sine 1/2 of theta equals, so if we want to cut that in half, we're going to do 2 divided by 2, cut it in half. We're going to do 1 minus cosine of theta. That's for sine. So kind of keep that in mind, and let's go back to page 255. All right, when we get back here, we see that the sine of alpha is exactly that half angle identity that we used, the square root of 1 minus cosine of 2a over 2. There it is. So we're just going to plug into this, and we're going to be able to figure out our sine A and our cosine A. We're going to need that to continue to do the rest of the work. All right, so to find 2a and a, we're going to go ahead and plug into this formula. This 2a equals b over a minus c. Make sure that you know what your coefficients are. So this is the a, this is the b, and this is the c. And so we'll go ahead and plug into those things. From that, just like we did before, we're going to find out what our x and y is. We're going to find out what our r is, and we're going to be able to build our trigonometric functions based on our sine and cosine and then our tangent. So you get the values for those things right there, and then you're back onto this big, nasty, disgusting algebra problem right here. Okay, so plug everything in. Here's the trigonometry part of it right here. And now you're onto algebra right here. And then it's just a bunch of algebra. Notice that it says that they skipped several steps. Yes, they did. And then they get it into its standard form. Notice that we have a hyperbola in this one because we have the positive negative xy. And then we just graph it like we did hyperbolas. How do you do that? Go back to the lesson previously on graphing hyperbolas if you're struggling there. All right, lots of information there, right? I mean, there's all kinds of things going on, so hopefully that made sense to you. Hopefully you were able to follow the progression. I know I didn't do a ton of it on my screen, so I didn't go through it. It would have taken me 30 minutes to go through each one of those steps. So follow the video, follow the progression, follow the steps in the book, and practice these. Practice is going to make perfect. It's going to be hard. It's going to take you a long time to get through these. These are not easy questions, so spend the time that you need to go through each one of these separately. All right, that's all I've got for you. Hope you learned something there. If you missed it, slide it back, watch it again. We'll see you later. You have a good one. Bye-bye.